Hi, welcome back to this video in which I will talk about handling partial failure. In this lecture, I will explain how to create resilient and fault-tolerant microservice architectures that handle partial failure when services are synchronously communicating. Before starting, I have to recall that the purpose here is to create a reliable system that is able to deliver its services as designed, even one or more of its components fail. So this presentation is structured as follows. I will illustrate the problem we are trying to solve through some examples. Then I will propose the typical solution we can adopt in such situations. Let's consider a scenario inspired from the food-to-go application where the order service is unresponsive. Mobile client makes a REST request to an API gateway, which I will present and explain in more depth in the next video. An API gateway is the entry point into the application for API clients. The API gateway proxies the request to their irresponsive order service. Naive implementation of the order service proxy would block indefinitely, waiting for a response. This will not only result in a poor user experience, but in many applications, it would consume a precious resource such as a thread. Eventually, the API gateway would run out of resources and become unable to handle requests. Then the entire application would be unavailable. The learned lessons here are, in a distributed system, whenever a service makes a synchronous request to another service, there is a never-present risk of partial failure. Because the client and the service are separate processes, a service may not be able to respond in a timely way to a client's request. The service could be down because of a failure or for maintenance, or the service might be overloaded and responding extremely slowly to requests. Because the client is blocked waiting for a response, the danger is that the failure could cascade to the client's clients and so on and cause an outage. For all that, it is essential that you design your service to prevent partial failures from cascading through the application. To do that, there are two parts of the solution. The first part is to design and develop robust remote procedure invocation proxies to handle irresponsive remote services. And the second is to decide how to recover from a failed remote service. So let's discover first how to develop a robust API proxy. Whenever one service synchronously invokes another service, it should protect itself using some solid techniques. Netflix described a useful approach consisting of a combination of mechanisms. You can find the link of the original article of this approach in the video description. In a nutshell, Netflix recommends using three specific techniques, which are network timeouts, limiting the number of requests, and using the famous circuit breaker pattern. Using timeouts when waiting for a response ensures that resources are never tied up indefinitely. The second mechanism recommends imposing an upper bound on the number of outstanding requests that a client can make to a particular service. Let's say, for example, a client sends 4 requests to the order service, and the number 4 is also the upper bound of requests that can be sent. Then the 5th request will be blocked. If the limit has been reached, it's probably pointless to make additional requests, and those attempts should fail immediately. Concerning the circuit breaker mechanism, let's consider this simplified scenario to understand how does it work. Let's say a client sends a first request, which works well. The second one works too. Meanwhile, our circuit breaker is already configured on the on state. Suppose now that the order service becomes unresponsive, then the following 3 requests will not be served by the application. After this number of failing requests, the circuit breaker switches to the off state, which means that no more requests will be served by the application and that we have to wait for a while till the order service becomes responsive. After that, the circuit breaker switches again to the on and accepts the received request from the client. As a summary, we can say that the circuit breaker pattern tracks the number of successful and failed requests, and if the error rate exceeds some threshold, trip the circuit breaker so that further attempts fail immediately. A large number of requests failing suggests that the service is unavailable and that sending more requests is pointless. After a timeout period, the client should try again and, if successful, close the circuit breaker. To implement these three techniques and others, you can use some open source libraries such as Netflix Hystrix or Resilient4G if you are using a JVM. If not, you should use an equivalent library according to the programming language you use. Using the circuit breaker pattern is only one part of the solution. You must also decide on a case-by-case basis how your services should recover from a non-responsive remote service. One obvious option for a service is to simply return an error to its client. In other scenarios, returning a fallback value such as a default value or cached response may make sense. But if we take the example illustrated in this figure, the API gateway implements the get orders endpoint using API composition. It calls several services, aggregates their responses, and sends a response to the mobile application. The code that implements the endpoint must have a strategy for handling the failure of each service that it calls. Actually, it's likely that each service's data isn't equally important to the client. The data from all the service is essential, and if this service is unavailable, the API gateway should return either a cached version of its data or an error. The data from the other services is less critical, and the client can, for example, display useful information to the user even if the delivery status was unavailable. If the delivery service is unavailable, the API gateway should return either a cached version of its data or omit it from the response. To sum up, here are the main ideas you have to keep in mind. In order to prevent failures from cascading through a system, a service client that uses a synchronous protocol must be designed to handle partial failures. Partial failures in microservices are situations when an invoked service is either down or exhibiting a high latency. To handle partial failures, we have to use timeouts when making requests, limit the number of outstanding requests, and use the circuit breaker pattern to avoid making calls to a failing service. It's also recommended to wisely decide how to recover from a failed remote service. That's it. Let me know in the comments if you have any questions, and don't miss the opportunity to watch the next videos of the series by subscribing to the channel and activating the bell. See you in the next video.